Okay, it's now good time to start. Thank you everyone for coming. Welcome to our NixOS meetup, Bay Area NixOS user group. So we have, this is our second meetup. So last year in July, we had the first meetup, kickoff meetup. And this is the first meetup in 2017. Yeah. So, and I'm sorry. I would like just to know how many guys are really beginner of Nix? So if you, yeah, so I expect lots of people, right? And how many guys are kind of expert? I mean, have used the Nix for some time. So okay, it's good. So this meetup definitely expected that lots of people should come as a beginners because Nix is very new technology. So we will have the John's presentation, and he also give very pedagogical introduction of how to set up the environment. And after that, we can have just free hacking session, and also you can ask whatever you want to know. And yeah, the people like me, I have some experience, so I can help you, and you can ask others to know, and you can share the information. So that's the purpose of this meetup. And okay, now I introduce John Wigley, and he will talk about Haskell and C++ development environment on Nix.
I have a URL up here. If anyone wants to clone it, there will be little snippets of code I refer to in this talk, and they're all in there. That is the repository where I keep all of my Nix-related configuration and scripts on my system. So I've sort of evolved over time. I've been using Nix for about 3 years. I've evolved some ways of doing things, which in some ways it's good because that's given me enough time to work out all the kinks. In other ways it's not good because Nix has been constantly evolving, and some ways that I do things are the old ways of doing those things. And I don't yet know for myself which ones are the new ones and which ones are the old ones. So if you show some of my code to someone who's just brand new gotten into Nix, they may say, oh, there's a better way to do that. So I disclaim any modernity in this Nix config repo, but it does work. And I was using Nix all day today, so a lot of these examples are just going to be real life examples. When you first install Nix on a machine, I'm not talking about NixOS. I actually do also use NixOS at home for a file server, but I do not use NixOS for development. This is a MacBook Pro here. I have macOS installed on it, Xcode installed on it, a few apps from the App Store, but all of the open source that I use through Nix. So I have Nix packages, the Nix package manager installed on this machine, and everything that I want to use, including Takt, I do it all through Nix, because Nix has such a beautiful way of managing and installing and versioning all that kind of stuff. Just didn't make sense to use anything else. And I have used almost every other package manager that's available. So I started with MacPorts, I went to Fink, I went to Brew. I've tried them all and was dissatisfied for various reasons with each of them. But when I came to Nix, it was just a dream come true. And it's gotten better over time. There's more community now, there's more going on, there's a lot more people working on getting expressions up to date, keeping packages up to date. So it's just become a better and better user experience as time has gone on, and yet it's kept all the fundamentals that drew it to me. So when you first install Nix on your machine, on your Mac, if you've installed the Nix package manager, you basically have two things that you're caring about: your user environment and the store. The store is accumulating all the binaries of the things that you build, and the user environment is where you're installing references to these binaries. Your user environment is going to be represented from your home directory by a directory called .nix-profile. And if you look under that, if you have Nix installed in your machine right now and you look under it, you'll see that there's a directory tree under there like you might see in user local. Except there are no files in there. Everything is a symbolic link into the store. And these store paths are important in that, let's go open my store. Whenever I want to build something, there is an expression, we call it a Nix expression, describing how to build it. And that will say, I want you to fetch from Git from this URL, I want you to use auto tools to run autoconf, then run configure, then run make install, etc., etc. These expressions will have dependencies on other expressions and so on. So one expression might actually refer to, say, 40 or 50 other projects. When Nix reads in the expression and decides, I need to create the build recipe you're going to use right now, it makes a derivation, these little DRV files, which contain in them just a ton of data about all the things relevant to building this package in your current environment. And you'll see that these derivations get these hash numbers. And what's cool about these hashes is that when Nix takes the expression, it takes the text of the expression, it takes the tarball that it downloaded, it takes all the other expressions that it depends on and their hashes, and it comes up with a hash that represents what it means to build this package at this point in time. So that if anything else ever changes anywhere along the line, this hash will change, which will be a signal to Nix that it needs to rebuild the derivation, because it will be a new derivation. And then each derivation results in the building of a binary tree here, a directory tree. They're in gray with the red lettering here. These are the final actual binaries that are being built by Nix. And they too get hashed. And everything in these binary build trees is a read-only file. This stuff should always be exactly the same. And in fact, at any given point in time, you can ask Nix to check the store's contents. And it'll walk through the contents of the entire store, checksumming everything, making sure that all the checksums match the directories that they sit under. And that becomes important because if you install something and then you uninstall it, you remove it from your user environment, it actually doesn't go anywhere. The store is just ever growing until you ask it to be garbage collected. But it will not touch the store for you. It'll just accrue in it. And then if I installed something and then uninstalled it and then decided I wanted to install it again, it's just going to say, okay, it's there now. Because it can see that the thing that it would have built is already there. Now that's not so significant on a local machine, but if you can refer to a remote machine, which we call a binary cache, it can do the same thing. It can say, do you already have a binary directory with that hash? Oh, you do? I'll just download yours then and install it directly into my store. Nix comes with a default reference to its own binary cache, which they have a build server farm that's always building all these expressions and all their various permutations. If you are at the bleeding edge of Nix development and you're tracking the Nix packages repository straight off of Git, you might get out of sync with that and end up building a lot of your own stuff locally. But if you're watching a release channel, which is your default setting after you install Nix, you're going to be watching the unstable release channel. That keeps up pretty fairly well. And so a lot of the time when you're installing things with Nix, you're not building. So it's got a lot of the nice things about Brew, but it's got this advantage that it can make use of these binaries because it knows what the result has to be hash-wise. So that's just a little overview of the environment and the store. So now about Haskell development. How many people here are Haskell developers? It's like 60%, 70%. Okay. So I'm going to use a little demo project here, which is actually a Haskell implementation of the Nix environment called HNix. It can, right now, the best it can do is it can parse all the Nix expressions that are in Nix packages, but it doesn't do much else at the moment. Now, in this project, this is a typical Haskell project. I have all my code, my documentation, and then I have my Cabal file. I don't want these Nix files in here. Well, that was the wrong thing. Make sure. Okay, so I'm going to get rid of all those Nix files. This would be like a typical Haskell project with a Cabal file. The first thing I want to do to work with this is you want to install Cabal 2 Nix into your user environment. I already have mine in my user environment, so I'm not going to run that. But that's the first tool that you would want. And the other tool you would want is Cabal install, which will be the current Cabal install latest version. I'm going to talk a little bit in a moment about how to have multiple versions of these installed, but for now, those two tools you usually want at user scope or easily accessible. So we're going to run Cabal 2 Nix, and I'm going to say in the current directory, just use whatever Cabal file you find and output the build instructions for that project to a file called default.nix.
Are you in a Nix shell right now?
I am not in a Nix shell. I am just in a typical regular old bash shell. And this is what Nix generated for me. This is the entire build recipe needed to build every aspect of what's represented in that Cabal file. So the library, executables, tests, any options well, not options, but whether it's building a library, whether it's building an executable, and it makes the reference for this be the current directory. So it says whenever the sources in this directory change, if the hash of the source files changes, consider that necessary cause for a rebuild.
What versions of libraries? You're kind of on the NCWLT. I'm assuming there's like upper and lower bounds of all files.
Yes,
right?
yes. However, that is not going to be what Nix honors. Nix is not like building with Hackage. It does not try to find a build solution of compatible versions. It will use the versions that Nix knows about for the current version of GHC. And it may not work with this Cabal file. You may try to run it and then you'll get an error from Cabal saying, I couldn't find version such and such of text. And you'll go to Cabal Hackage and you'll say, well, it's there, but then you'll look and you'll see that Nix is not using that version. So Nix is not trying to provide you with every version of every package. It is providing you with one version of a package. And that version is always moving forward, release to release. Or if you're tracking the Nix packages repo, it can actually move daily. There's a guy, Peter, who runs a script that scours Hackage, finds all the latest version numbers, and updates all the expressions. And he does this at regular intervals, like every few days.
But there's other people who do it with like a nightly, and they're like the Hackage maintainers. So.
Even Nix package uses a package, the latest version.
Yeah, and you can also have Nix use a specific release of LTS.
Yeah, you can use like predefined LTS.
Awesome.
Yeah. Now, because there are some packages that when they move forward in Hackage, it breaks the entire world. What Nix's answer to that, or Peter's answer to that is he'll make the package underbar version number. And that'll be the new version. Like Servant, when Servant went from 0.8 to 0.9, that broke a ton of stuff. So when you referred to Servant, you were referring to 0.8. You had to actually say Servant underbar 0, underbar 9, underbar 1, underbar 1 to get that version of Servant.
And you can also, in your own environment, just define an override.
Right, right. And I'll show you overrides in just a minute. But the default using Cabal 2 Nix will be to say, give me what's in the default Haskell environment for Nix. That's my default.nix file that I need for building the project and installing it into my store. Usually for personal development, you're going to want a different file. So if you run Cabal 2 Nix and you give it the option --shell followed by a dot, and then you redirect it to a file that's commonly called shell.nix. This gives you a file that nix-shell is going to pay attention to. And usually the only command you really need to pass to nix-shell is Cabal configure. When Cabal configure runs, and you can ignore it complaining about Hackage being out of date, when Cabal configure runs, the manifest that it creates in the dist directory actually is populated with absolute paths. So from this point forward, I don't need to use nix-shell anymore. I can actually say Cabal build, and it will build this Cabal project in my current environment, but using all of the stuff from the Nix store.
Does that mean all your tooling that uses Cabal will work as well?
If it's using Cabal, it should work. If you're using like HDev tools or something, that may not be so happy, but there's a way to work around that. So let's stop that build. I could just say nix-shell. This drops me into a shell in which my user environment is now my global user environment plus all the dependencies needed by this package, including GHC. So in this environment, I don't have GHC. Even though Cabal build works, that's because it's got all these absolute path references inside the dist directory. But if I jump into nix-shell, I'm in the environment that this project needs to work. And so I have GHC available. In here, HDev tools will work. Also, if I wanted my Emacs environment, my Haskell mode, to get auto completion and all the other lovely stuff, I can just run Emacs from within the shell. And that's actually what I do. When I have really complex scenarios, especially with lots of interdependent projects that I need them all to see each other at an exact specific version, I will use nix-shell to build a custom on-the-spot environment, and then I'll run Emacs from in that shell.
So if you do that and you change your dependencies, you have to exit Emacs.
Yes, that is
You
true.
can and exit your Nix shell and rerun your Nix shell.
That's right.
But you can also run, I run Emacs from outside and then just there's some tooling you can use to hook into Nix shell from Emacs. So you don't have to,
I want to talk to you about that.
No, I've never used that because I do something a little crazier. Let's go to my config.nix file that's inside that repository I linked you to. One of the things that you will start wanting to do almost immediately after you get into Nix, especially with Haskell, is what we call package overrides. And this is where you change some attribute of a package that Nix knows about. So in the Nix packages repository, there might be an expression for HDevTools. But the HDevTools doesn't build with 802 for some crazy reason. So you want to go git clone HDevTools into your local tree, do your hacks in there to make sure it works, be a good citizen, make your pull request. But now you need Nix to use that HDevTools, the one you've just hacked. And so you do this with a package override. And the package override syntax, I'm not going to get into all the details here, but this keyword followed by a colon, this is actually defining a lambda. So if you were a Haskell person, it would be this. And let is just doing what let does. It's a pure functional language that has no effects. It just declares these different things here. So I have package overrides is a function that super refers to the unoverridden environment, so the native environment. So at any point in time, I can say super dot to refer to my unmolested version of a package. I also get, let's see, yeah, and then I say self, okay, fine. So inside package overrides, I define an attribute called my Haskell packages. An attribute is this is kind of like a key value dictionary here, where the keys are to the lefts of the equals and the values are to the rights of the equals. In the package overrides, I'm defining a map where I have a thing called my Haskell packages. This is not special to Nix. This is just a word I came up with. And I define it to be a function of 3 arguments. So using currying, I just triply nest lambdas here. And in it, I have references to every single local package or local Haskell project that I work on, so that I can refer to them by name as if they were part of Nix. Instead of having to CD all over the place to use Nix shell, in here I compile sort of the list, and there's another reason I do this I'll get into in a minute. But this PKG here is just, I'm using let to define this variable PKG equal to the function self.call package. This says in this directory, you're going to look for a file called default.nix because that's the default name to look for, and just load in its contents. And then the braces here say that I'm not overriding anything that's being defined in that file. I'm not passing any arguments to that file. I just want you to use what's in that file. So this way, async pool, I now have the async pool default.nix, and if I go over there, yeah, so I just have what Cabal 2 Nix generates. I never bother to commit these to my project because they're so easy to regenerate, and you never edit them. So anyway, the my Haskell packages has all these packages, but then it has these, which are my overrides and changes to hackage. So for example, I have Agda building on my machine, but Agda takes absolutely forever for the haddix to run. It takes longer to do the haddix than it does to build Agda. But I'm never looking up the documentation for how Agda is built, so I want to say don't haddock Agda, and boom, it won't generate the docs now. Do jailbreak is a macro that says ignore the package constraints. Just try to use what Nix has defined. And as you can see, it's a successful strategy. It works on quite a lot of packages. Don't check says the tests don't work here. They don't work on Mac usually, so just don't run the tests. And then I have here an example where I'm ganging these up. So each one is modifying the expression, and it can keep going. You can keep chaining them. So I have do jailbreak, don't check. I could have put don't haddock. And then here I wanted to change servant to be servant 0.10, but it didn't. They changed the type in one of the client libraries, so I haven't done it yet, but I'm going to. There. And then here I have Haskell 802 packages, where I take the super environments haskell.packages.ghc802 and I override it. And I say, I want your overrides to come from my Haskell packages. And then lastly, I do a little trick here. There's a neat feature in Nix called Myenvfun. And what this does is it lets me specify a list of dependencies. And here I have Alex, Happy, GHC, GHC core, HLint, Hask tags, et cetera, and there's Agda down at the bottom. But instead of installing all of these into my user environment, when I install that, it is going to, see, I installed it here as envghc80. This adds in a shell script called load envghc80. When I run that shell script, I am put into a shell that has all of these dependencies visible. So this is an on-demand environment. And the reason why I like this is because if I tell Nix, hey, I just pulled Nix packages from the repo, go rebuild everything that's been updated, it'll rebuild this environment. Whereas if you do the Nix shell solution, where you just sort of like extemporaneously pop into a shell with a bunch of dependencies, if Nix has updated since the last time you did it, it might need to go pull things and build things right then. So I do a lot of work from airplanes. I want to make sure that it never has to go outside my box. So I want everything when I say update to be updated so that when I lose internet, I can keep working. And that's why the Nix shell solution, although it's kind of neat for little one-offs, I like encoding these canned environments in this way. And the other thing you can do with a canned environment like this is I'm importing here, you see this package list. Well, this is every single package that I ever care to reference for any reason. They all get installed in this environment. So this is like a beefy slice of package available to every shell that I ever open in my terminal, not specific to any project. And so I can be in Emacs and I can edit the HS file from pretty much any project, and all the type checking works and all the auto completion works because I've got every freaking dependency being loaded. And better than that, I don't just have the dependencies being loaded, I'm loading them with this function called GHC with Google. This says don't just install these packages into this Myenvfun environment, also install the Google databases and make it so that the Google command can look up the documentation for every one of those packages. So I'll show you how that works. I go into a file I was working in today called repair, and I come down to, I don't know, like from maybe, right? I type a little key that I have in my Emacs environment that does a Google query, and I hit return, and at first it never gets it, but if I refresh, it'll be there. And it'll just jump me to a Google search for that keyword, and then I can go here. And all the sources are also, take out the trash maybe. All the sources are also installed, so I can just jump to them as well.
And that's a HTML file in your Nix store.
It's an HTML file in my Nix store. That's what GHC with Google provides that for you. It also provides for you the Google command, so I can just say Google head, and that'll work straight from the Google.txt database. This is and it uses Google 5, so it's using the new Google, which is quite quick. So that's the advantage of an Myenvfun with a crafted set of pre-canned dependencies and using GHC with Google. You pretty much are carrying a huge amount of Haskell tooling with you wherever you go. You've got a big section of package. You've got the functionality of Google. You've got the documentation for everything. I almost don't need the internet most days at all. And I have this also set up for profiling as well. So I have the GHC 8.0 environment that's using the 802 compiler. It's doing this because of its reference here to with Haskell 802 packages. But I also do a profiling version of it where I install a lot less tools. I don't care about a profiled Agda. I also don't install the Google because I can just open the documentation in a Google shell. But what this gives me the ability to do is I can go over here to, let's see where we were, in HNix. I can edit my shell.nix. Unfortunately, I can't do this with a sexy command line invocation. I actually have to change this in here to pro-life. Okay. Different meaning. Profile Haskell 802. Okay. And then now when I do, I want to remove the disk that was put here. Now when I do the Cabal configure command, I want to enable profiling. And now when I build, it'll go through and build the Haskell.os, and then it'll build the p_.os. And every dependency is built with profiling, so profiling will just work. Anyway. Okay. So I mentioned those guys. Okay, so a companion to Myenvfun is called Buildenv. Buildenv is exactly what Myenvfun is, except the dependencies don't get stuck behind a shell command. They get put into your user environment. As you can see here, my user environment, which you can always see with NixEnv-Q to query your environment, I don't have very many lines there. And the reason why is I've got all these aggregate groupings here: Git tools, Lang tools, mail tools, network tools. Every one of these is a Buildenv that has a whole bunch of dependencies. And that way I can upgrade these guys piecemeal if I need to. I can say, oh, update my mail tools, but that's the only thing I want to upgrade right now. And then also, I mean, I have pretty bad OCD. I just don't like seeing hundreds and hundreds and hundreds of package names in my environment, all interleaved, not knowing which one goes with what. I like having these rational, well-grouped sections of packages. And then every once in a while, a change will happen in the Nix packages repository, and I'll need to comment one of these out and then just rebuild that tool's Buildenv. So that's pretty much what I do here. All these env guys are my Myenvfuns. So I've got 3 versions of Coq and all their libraries built with each specific version. I've got the current head version of Emacs and then another build of the head version of Emacs because I use a separate Emacs for IRC. I've got GHC 802 and profiling. I used to also carry around 7.10.3 and profiling, but too many things in the package environment started not working as the dependencies moved up in version and work moved to 8.0, so it wasn't worth keeping around anymore. And then I have these 2 C++ environments. So one of my open source packages is Ledger, is written in C++, and Ledger uses Boost, and Boost has a library in it called Boost Python. But if you want Boost Python built against Python 2 or Python 3, a whole bunch of stuff needs to be rebuilt. Otherwise, you're going to get seg faults in the weirdest places. And so what I can do then is I have a Ledger Pi 2 environment that has CMake and Boost and everything there. And then I have another one, Ledger Pi 3, that refers to this Boost with Python 3, where I took Boost, the Super Boost 160, and I overrode it to say Python should be Python 3 in that version of Boost. So you can see that overriding is actually pretty expressive, and the syntax is pretty clear to see, well, what the heck was I doing? Not saying that's always the case. You can get yourself into situations in Nix where somebody will cargo cult you a piece of something for your config.nix, and it's anybody's guess what it means. Or yeah, it's a pretty simple language though. I mean, it doesn't do very much. It just has lists and strings and these key value mappings and lambdas. It doesn't do a whole lot else. So there's not very much to know. For building Emacs, I say globally that Emacs should be always this head Emacs, and the reason why I do this is that if I install anything like TechLive that anywhere down in its dependency chain wants to depend upon Emacs, I want it to come back and depend on the Emacs I care about. And then I override Nix's build of Emacs with my own recipe that works with the current head version of the sources. And then I have a version of this that turns off checking, turns off the tests because they take so long to run. But if at any point in time I want to, I can use Nix shell to drop into the head base environment, and then I'll be able to build and run the tests. And that's pretty much everything that I've got happening in the config.nix there. Oh yes, there's one more thing. When you create a, let's see, where were we? HNix. When you create a default.nix file, you get this very handy source equals dot/dot. And that's cool because it means that even though you can refer to this from config.nix as if it were a global package, it will know from that that the SHA is to be built from the contents of the tree. So anytime you change any file, that will cause a rebuild of that. It's not always what you want. You don't always want every single file. So I was finding, for example, that every time I did a git pull, even if nothing changed, but other branches changed so that the contents of my packs or my objects folder changed, it was rebuilding stuff. So you can fix that with defining in your overrides Haskell filter source. And this is a lambda of 2 arguments that takes the paths under consideration and this SRC, that I have no idea what it means. Not unfamiliar experience with Nix. Oh, yeah, you just have to hand it in at the end here. And then I call a function from the Builtins, which is the sort of like the standard library for Nix is called Builtins. And then I do things like I say, I don't care about directories with these names, .git, cabal, sandbox, or dist. And I don't care about unknown files. I only care about regular files or symlinks. But I also don't care about anything that has this for a suffix. So all these various build products that Cabal might leave around when I'm doing Nix shell style development. And then this pretty effectively cuts out all the junk whose transient changes shouldn't be causing my user environment to be changing.
Sorry, where do you put that in your, where do you use Haskell filter source?
So this package overrides environment, it's a key within that environment. So at the same level as this my Haskell packages, you would define Haskell filter source.
Oh, that's a built-in?
Yeah, it's built in, quote unquote. Peter's Haskell packaging machinery will look in the overrides environment to see if you've defined this, and will use it. You can also do, you can use Builtins filter source like right here too. You could say filter source, and then have your, your lambda, blah, blah, blah. You could do it. And in some cases you may, if it's not a Haskell project, you may want to do that. Okay, so there's a lot of stuff that I build. In fact, I build just shy over 2,000 build expressions when the world gets changed. And when I say the world gets changed, sometimes people will commit a change to the Nix packages repository that is what is called a Buildenv change. That means the build tools Nix uses are considered to have changed, which changes the SHA of every single thing it builds, meaning everything rebuilds. And when that happens, like I said, about over 2,000 packages of mine get built. So that's a lot of churn, and I try to do it nightly because I want to stay on top of these breakages, and I submit bugs when things break. But I don't want to be just burning up my laptop here or wasting away its SSD. So I have a much bigger machine at home that does that build, and it starts it every night when I'm in bed. But I also want the exact same stuff here on my laptop without having to build it a second time. So there's this very cool feature in Nix called Nix copy closure. A closure is any path in the store and all of its transient dependencies. The Nix people call that a closure. So if I were to refer to the Nix closure of, let's see here, of envghc80, it would be all those Haskell libraries and GHC and everything GHC needs and all the libraries like zlib that some of those Haskell packages need. And you can copy a closure from one machine to another. It'll go straight out of your store into the other machine's store. So I have in my Nix config directory, I have a little script called copy Nix that takes a host name. And it says Nix copy closure to that host name that needs to be accessible by SSH. And then I use this little trick of calling read link on my Nix profile directory. Because I said that your .nix-profile is where your user environment lives. So that actually is a symbolic link itself. It's a symbolic link into a directory that contains every past generation of your user environment that you've used, with a default referring to the current one. So if I read link on this, it will be a hashed, yeah. Relink my stuff. So this actually, my user environment gets its own directory because, and this is the directory that's full of the symlinks, and it gets a hash. So the closure of this is my entire world. So if I've done a full Nix environment rebuild and I say Nix copy closure to this laptop, some days it will say, oh, I'm copying 20 gigabytes now. And then I come back about an hour later and it's done. But at least my laptop didn't have to do what would have probably taken 7 to 8 hours for it to build. The other thing that you can do is if you have multiple machines, or if you're going to be on the road and your machine at home is nightly building and you want to be able to use those things it's building without triggering huge downloads, you can set up a binary cache just like the Nix people do. And I have that set up. I won't go into too much detail on how that works, but in my Nix packages, there is a push Nix, which is what I call after I update my Nix environment. And it does this thing where it'll upload these signed binary blobs. And then in this directory, there's a nix.conf, and you'll see at the bottom, this is how you would use my binary cache. So if you're a Mac developer that's using Haskell, feel free to use those lines and make use of my cache if you want to, because I build really often. And I have got tons of bandwidth on the server where those caches are living. And then lastly, I'll give a little plug here if anyone wants to do hacking for fun on HNix. There's several people working on HNix now, and what we'd like to do is we'd like to replace Nix, which is written in C++, with a language that is closer in spirit to the very things Nix is trying to achieve. So we've got a complete parser, we've got a complete pretty printer. Work has just begun on the evaluator, and then also someone is working on the store library replacement. That's for putting things into the store and getting things out of the store. And that's also at my GitHub under HNix.
That's going to be a strongly typed language?
We want to add typing. At first, opt-in typing, and then maybe upgrade to a version of the Nix language. Like instead of having a .nix file, you have a .hnix file, and that would be a flavor of Nix that would require typing. Kind of like what Gabriel's doing with his thrall language. He's giving you an alternative typed way of expressing Nix expression. Questions?
So this is kind of pedantic, but there were a bunch of like tildes in the paths that you had in that file. So doesn't that sort of introduce like a dependency on the home variable?
Yep.
Okay.
I've never tried building it from a different home directory.
But like more generally, are environment variables like captured in like the hash of all the dependencies, or are they sort of like a?
If the expression makes use of them, yes. Yeah. Because the derivation file will contain the part of the environment that build of the expression depends on.
Awesome, I didn't know that.
Yeah.
So anyone who wants to use your binary cache is going to have the same username as you.
No.
I don't think this will affect the environments I've installed in my user. I don't think it will affect the Haskell libraries that I built, because those don't depend on my home directory. Just these guys, just this, the envghc0 might.
What's the magic in your, in your binary cache update thing? What's the magic that got the signature to work?
You generate an SK and PK file for your secret and public keys, and then you just refer to your secret key. And you put your PK where somebody
Are those
can find
just
it.
OpenSSL? Like,
Yeah.
Okay. Thanks.
It takes a while too, because it has to compress it takes the directory full of the binaries and tars it or archives it into a NAR file. And then
Yeah, I do the binary cache myself. I just don't sign it because I couldn't figure out how to do it. I think it was before they added the signing.
Yeah. Yeah. So that one I did recently. That's why I'm doing the right thing with that.
How does this work with Stack, or does it work?
I am not a Stack user.
Does not.
Yeah, I've never tried Stack.
You can install Stack. We were talking about this earlier before the talk started. They track LTSs, so you can use those as your Haskell package set rather than the default. So if you want to track like LTS 7.13 or something, you can get that version, and you can install Stack from Nix.
But for the most part, they're kind of separate as far as like, I have a separate stack environment that I install from Nix shell when I want to work in stack. But for the most part, you don't really need to unless you're trying to test stack or something.
Right. And Cabal sandboxes don't play very well with it either. What I usually run into sometimes when I've tried using them is the moment you get to a Haskell library that needs something like zlib, it'll fail to find zlib because even though it's in your store, you have to pass special options to Cabal for it to see the zlib, and you end up replicating what you would do by just having Nix do it. And Nix is sandboxing. I mean, it's effectively sandboxing everything, but with sharing of binaries everywhere. So you only have one version of a library installed for each particular environment.
Do the SHAs lock everything down such that people can't host like malware on their binary cache servers? I'm not sure whether it is gonna, it ought to confirm the SHA after downloading the NAR file. That would make sense. But don't install malware assuming that I'm right on that. I haven't tried that.
And your signatures should protect against that too, right?
Yeah, well, definitely.
I'm pretty sure it does because I often pull something out of Git and I don't update the SHA. I just update the rev and then it complains.
Okay.
And then I use that to update the Nix file.
Yeah.
With the right SHA. So at least when you fetch from Git, it checks the SHA.
This command here, Nix store verify repair check contents, is also one I like to run from time to time. It will go through and check the checksums of everything, verify that everything that should be there is there, and then anything that's broken or doesn't have the right SHA anymore for whatever reason, could be bit rot, it'll go re-download it and fix it. It takes a long time to run this.
So I'm a complete Nix novice. Am I gathering that Nix is sort of like one of the reasons we use stack is because we get a consistent Haskell ecosystem. So if I use Nix, not only would I get a consistent Haskell ecosystem, but say I had a dependency like PCRE or something like that, that would also be consistent because it would be, the scope is limited by my imagination as to what I put into the Nix config as to what's actually guaranteed to be.
Yes. With Nix, you're getting versioning and tracking of everything down to the bottom. If you're running NixOS, down to the kernel.
Yeah.
Now also divide between stack and stackage. So stackage is the work of several individuals who are curating packages.
Yeah.
And they're working with a whole group of people to make sure that everybody's stuff works together. Nix can take advantage of the work done on stackage.
That was the reference to they track the LTS.
Exactly. Stack as a tool is giving you a Haskell land only rendition of some of what Nix does, some of what Cabal sandboxing does, some of what Cabal new build does. It's just their tool for giving you a better front end to dependency management.
Right.
But the real value of the whole stack ecosystem, I think, is in the stackage stuff, which you can still take advantage of.
So this is a Linux box and it's not running NixOS. Okay, so I have a whole bunch of stuff from Fedora, like just loaded on here already. But were I to put the Nix package manager on here, right, it would sort of put a layer of Nix in front of all this
Exactly.
default.
Yeah, it can completely coexist.
Yeah. When you do your copy closures, do you ever do that from like a Red Hat box from a NixOS box to a Red Hat box? That should work.
No,
right?
I've never done it.
I think that works. I'm under the impression you can actually push a whole closure which is your Haskell package plus all the binary dependencies and any library dependencies. And you just copy closure and it just SSHs an environment to a Red Hat box or wherever. And then that's basically itself, and all the links, all the symlinks and everything are set up correctly. So you can just run that as basically a container.
My understanding is that that works with NixOS and not necessarily with other Linuxes.
Okay.
But the nice thing is that it works with different versions of NixOS. And I believe also different kernel versions.
It's sort of like Nix
That is amazing.
Kind of like even does what Docker does, only better. So.
Yeah, it depends on the dependencies. Usual practice it works. I actually the experience that I used the Nix on Arch Linux for some time, and at the time I can just download the old
copy closure.
Copy closure.
Oh, that's awesome.
Yeah, and so it's Hydra machines. Yeah.
And if you're a Docker user, there are ways to turn
Yeah.
what's effectively a closure into a container. You just have to include the base dependencies.
Yeah.
I think I missed the trick where you actually said which version of the LTS you're tracking, or is that?
I don't use stackage.
Okay.
But if you Google for Nix Haskell stackage, you'll see the instructions.
I've used it before, and I think they track them all. They may lag by a couple of days, but I think it's all automatically generated, so it's not like I could be wrong about that. They used to automatically generate it, and I think that was just getting. They used to track stackage in the main package, and then I think they stopped that a few months ago, and because it's just a maintenance issue or something. But
How do you know which GHC to use when you're just looking at the latest packages?
So there's in the Nix packages global namespace, there is a package called Haskell packages, which refers to the current Haskell package set. And underneath that, the GHC would refer to that GHC. But you can also say Haskell dot, and let me get I don't usually do this, let me get the name right, yeah. So you can say haskell.packages.gc, and then you can give a version. And you can go all the way as far back, I think, as 6.2. I could say 710, GHC 710.3.gc. And then that would be the compiler for that GHC 710.3. And then this packages environment would be the dependencies of package that they sort of froze for that version of GHC. Because in addition to the several stackage sets, they also have alternate package sets. Although they're not very well maintained, I have to say. Over time, the GHC will still work and build, but the package libraries you're going to refer to, you're going to get better and better luck doing it yourself by hand tuning. I didn't mention one thing, which is if you're a person working on a large project that has lots of sub-dependencies, let's see if I have such a project somewhere. Yes. You can create a default.nix in there, which isn't just for one Haskell package, it's for the whole project. And that will give you a way to easily have a place outside of your personal config.nix to define things like Myenvfun for your project. And then you could commit that, and your coworkers could download it into, or when they pull, they'll get that default.nix, and then they could say, oh, I want to build the tests, or I want to build this, or I want to build that. And then you as the Nix engineer can have already set that up for them. And I've done that at my workplace for this project we were working on here called Crash, that has a whole bunch of stuff in all kinds of different directories. Let me make this just a little smaller. In fact, let me edit this into Nix. Just to give you a feel of what this type of file will look like. And I started out with all these directions on, because they were not Nix people, the other people on my project using this. So I was just telling them how to use it. But basically, you inherit a, I'm saying here what Haskell package environment all of this is going to depend on. So this is depending on the 7.8.4 version of GHC. And then I pull in some stuff from the global environment I want to call here. And then I say that whenever you reference a package with call package, first look in the global environment, then look in the Haskell environment, then look in this Haskell depths set, which I'm going to define below, then look in these crash depths, where the crash depths are the dependencies that are specific to this project. So these are all the components that make up the crash project. Then
it's not that, I think you got the search order backwards. You're overriding.
Oh, yeah, right. You're right. Yes. So first look in the rightmost, then the left, then the left, then the left. Thank you. Haskell depths here is all of my overrides of the global environment because stuff kept breaking. So this was in the days when 7.10 was coming out, and I started running into those problems. And so I created a directory, a subdirectory in this project called Nix. And in it, I just started using Cabal to Nix and accumulating .nix files for all the specific versions. And the way you can do that is instead of like we said, this is how we did it for a regular Haskell project. Well, you can also say this. Is it like this?
Yeah.
Yeah. My machine's going slow because I'm building so many. I'm doing that check. Yeah. So this is how I would do it to download the build recipe for a particular version. And then over here in my project file, I would say call package and name that particular version. And then you can see up here, I say recurse into adders. This is a little piece of magic that says, don't only set unbound generics to that, set it everywhere. In everybody who ever refers to it anywhere, change their dependencies to that dependency.
Is this on GitHub?
You know what, let me make a copy of this for you. Because this is something I cargo cult myself. Yeah, we'll call it project example.looks.
Thank you.
Sure.
And that's in your Nix config.
Yeah, that's in that Nix-config. The way it goes. Okay. Any other questions?
So Nix is basically uses like a hash address store, right? Are there other projects that sort of use the same framework, like IPFS, with the idea being you have like one big Git repo sort of as a hash address store shared by a global like BitTorrent swarm? Would it be possible just to like use that as the backend or like for a build caching? And do you know if anyone's like tried anything like that?
We need someone to finish the store library for HNix.
Interesting.
No reason it can't be a new format.
There has been some discussion of that, yeah. One of the tricky bits is that the hashes that are in the Nix store are not content hashes of the build package.
Input hashes.
They're hashes of the inputs to the build function. So, like, I'm not really conversant on what that implies, but it's a kind of stomach block.
Did not consider that.
Was there any work with distributed builds on Nix? So like you talking about like hours and hours compiling stuff, if you have like 3 computers at home.
So there's Hydra. Hydra is Nix's answer to that, and it runs a build farm of machines that are producing these binary closures.
Have you set up a Hydra?
I have not.
Have you set up a Hydra?
Yeah.
It's very easy. If you use NixOS, then actually
It's pretty easy.
adding one line of
yeah.
configuration that Nix gives a Hydra.
So it adds a Unix OS computer into the cluster.
Yeah, exactly. And you can designate the different machines, several the worker machines for the Hydra.
Is it possible to integrate that into Nix ops and spin up EC2 instances?
Yeah.
Oh,
Yeah,
that's
everything's
awesome.
now
That's
built
amazing.
into the NixOS now.
That's amazing.
It's a very new development.
He mentioned Nix Ops, which is a Nix-based provisioning software, so that you can take a declarative statement of a machine and what binaries it should have on it, and just say instantiate this into Amazon.
As a side effect, could Hydra take and build binaries from many different platforms for a Haskell project? It's kind of tedious otherwise.
What do you mean platform? Like architectures?
Like for different kinds of Linuxes or whatever. Maybe there's not a need to, and I'm overanalyzing that it needs to be built for each kind of Linux. But like say I want to distribute a binary, and the binary is built from a Haskell project.
Yeah,
You can turn off, turn down flags off. So you can just specify what you want. I think.
I don't know. I haven't used Hydra. So.
In the talk, the title was C++ and Haskell. I noticed you had one project in C++. Is there anything interesting else that refers to C++, or is Haskell a bit more interesting?
Oh, so is there a universally accepted C++ packaging?
Nope.
No, so it's not quite as interesting.
Right.
It should have been Haskell and C++ in 4-point font.
An A project.
Yeah. I mean, I still regularly use it. I use it also for, and there was Emacs, don't forget. So that was a C project. So I use it for AC and AC++ project quite often.
I mean, in some ways, it's more useful for C and C++ because it lets you define what libraries you want. I mean, it is the packaging environment, whereas with Haskell, they're just tracking hackage. You know what I'm saying? So like Haskell has a way to deal with this. Python has a way to deal with that. And for my money, like it really shines over Stack when it comes to C dependencies because it will manage those and give you exact versions. Whereas with Stack, you have to say, you know, I think you add in your extra libs or something, right? Yeah. You put in a version and it goes and downloads the tarball or whatever if it knows how to get it. So I think it's more valuable for that.
When does it know how to get it? Like how does it know where to get it from?
Well, it's either in the Nix packages repo.
Right.
Someone has added it with a particular version, or you just write your own default.nix for it, which, you know, there's a language for building, which John didn't go over, but if you look at Nix, the package manager, it has many different build phases. It knows how to use autoconf automatically. Like for getting an autoconf project to build in Nix is like probably like 3 lines.
What about CMake?
Yeah, I use
yeah, he has CMake in there. I haven't used it myself, but
I'll show you the build recipe that I use for this C++ project.
This is actually super useful because, like, exactly for C++, there's no way to describe a project that will actually fetch it and
this
build them
it
all
does
and
that.
like isolate all of this. So this is actually super exciting.
So the only 2 things I have to say is I have so Nix already knows about CMake and it knows how to build a CMake project. So the only thing I have to do is I wanted to add this flag. So I have there's an attribute that it is sensitive to called CMake flags. And I can define that I want the install libdir to be lib. And then there is, he said phase. There are many phases that a build goes through. So there's a patch phase, setup phase, build phase, install phase, check phase. You can hook any of these phases before or after by simply setting an attribute called post or pre that phase name. So here it's post install. And this is a string that will just be executed as a bash script. So I want to say after you run the install target for the make file that CMake produced, make this directory and CP these files into that directory in this special $out. And this $out during build time will be a temp directory, but then it will get copied into the store. The only trick you have to worry about with doing building C++ executables or libraries, if you're using a lot of dynamic loading, is that if you have any RPath references in your executable, you have to make sure that they get written to be absolute paths. And so it's very common in the post-build phase of a C++ project's Nix file to use install name tool or some other like patchelf or something to rewrite the paths in the binaries for either the .so or the .dilib. To make sure that everything's always absolute, because that's what all of this hinges upon. Once a thing installs, if it works, it always works until the day you uninstall it. And that's what got me onto this off of Brew.
Yep.
Because Brew, my Emacs would be working fine. I would exit it for some reason and go to run it, and it just wouldn't run. I'd be like, what? Oh yeah, I updated libpng 5 hours ago, and it changed the API, and now I have to rebuild Emacs. And it's the worst thing in your workflow to suddenly realize you have to wait 20 minutes for something to happen. But with Nix, I can be speculatively building the next version of Nix. It will only change my user environment to that version of it if it can do it atomically. And
you can roll back too.
Yeah, and you can roll back at any time. So if I go here into my shell and I say nixenv, so I did -q, which showed me all the stuff that I have installed. I can do list generations, what I can spell. And this is all the generations. Now I've garbage collected, but you can see I've had 73 generations since I installed Nix on this machine. At any time I can say roll back to go to the last one. I can say switch generation and I can give it a particular number. So I can go anytime, anywhere back in time that I want to.
And I can also delete particular ranges of generation. So usually if I see a whole bunch of them, like within 1 hour on the same day, I know that only the last one's any good, right? And so I might keep the ones that are a day apart, like the last 5 such generations or something. So Nix is really good about that. And that anything that works in a past generation still works today. Because, and if you do the verify, repair, check content, you can even be doubly sure that that's going to be the case when you're off somewhere on a plane and you have to roll back.
So assuming I'm compelled by your presentation when I start doing this stuff, and you just said that it respects that attribute. How do I discover that it respects that attribute as someone who doesn't know already?
So this is really the soft spot in the Nix world right now, is our documentation and discoverability. Sometimes it's hard to know how to phrase the question for Google to even help you find the answer, because there are a lot of special attribute names that Nix is sensitive to, and it matters how you spell it. And then you're wondering, well, if you just can't quite get it right, what was the spelling of that again? So IRC, using the NixOS channel, the mailing list, asking people.
There's no such thing as autocomplete for attributes.
And also the user guide. There is a Nix user guide, of course, but there is also NixOS user guide, and then the Nix PKGS user guide. Nix PKG user guide has
They do document these special names there. So all the phases, all the trap hooks for the phases, for Haskell packages, all the special attributes for the Haskell build process, all like this GHC with Google, all of that is in the Nix manual, or if you Google for Nix Haskell development, you'll see that Peter's been keeping documentation up to date with all the specifics of the Haskell environment. I know, in fact, that there is a way, this one I haven't gotten working yet, but Peter tells me there's a way. I have a local mirror of Hackage, so that if I want to install something and I'm on the plane again, and I don't even have it installed, I don't have to actually pull the tarball either. There's a way in Nix to override where it goes to get Hackage sources from. And so then you can just point it at a local directory where you have a Hackage mirror set up.
So could you perhaps show us how to find what that attribute is?
Well, yeah.
I guess I'm putting you on the spot.
I know the name of the attribute, and I even know what I'm supposed to set it to. It's just that I haven't gotten Peter to answer my email as to why it doesn't work. So the Haskell builder has a function in it called MK derivation. And MK derivation in the Haskell code is the guy who's responsible for taking a set of attribute names and turning them into a set of build scripts. So there's going to be code in the Nix packages repository that defines this MK derivation function. And in it, you will see every one of the special attributes named and what it does with them. So this is all source code. You can read how this
That's what I'm
stuff
asking
happens.
for. Like,
Yeah.
where?
So
How do I teach myself?
if we went into, let's see here. If we went into Haskell development tools, no, it's got to be in the modules. Yeah. Okay.
And light up. Haskell.
Yes. Okay. So live.nix, MK derivation. Where's that coming from?
This is basically what it is, by the way. It's just, grepping through source.
Grabbing through source.
Yeah. All right. So MK derivation is based on code that's in generic builder. So that we have generic builder and we have generic stack builder. So apparently you can use stack as a builder. New one on me. Here's all the attributes defined that a Haskell recipe could use. Many of them having default values. And then down here is the phases defined in terms of those values. So Peter's doing a whole bunch of work here for you that you don't want to have to do. So the build phase, for example, says run the pre-build hook, then run the setup command, give it the build
argument, so we're assuming this is going to be cabal build, then give it the build target and the cross cabal flag string. I have no idea what that is. Then run the post build hook. So in the final, at the end of it all, it's going to be a bash script that's going to run. It's these Nix declarations that are building that up from all these attribute values that you specify. And the more abstraction you get, the easier it is to write the common pattern. But a lot of Nix gives you these hooks so that you can trick things into the lower layers when the common pattern isn't exactly what you need.
The Haskell stuff has changed in the last year, also the way it's built, so that makes it a little tricky because pretty much everything you find before like December 2015 is gonna be out of date.
Yes, yes.
And so that makes it tricky. You might want to filter by last year when you search. I think Emacs is going through the same thing now. So like Emacs, the way Emacs builds packages is changing right now. So Nix is amazing, but it's also changing really quickly. And someone needs to write a learn you in Nix, but no one's done it yet.
Because it would be wrong next year.
Yeah, right. It's like, cutting edge technology. It's awesome when it works, and it's really difficult to debug when it doesn't.
Or have a friend that you can send an email.
I learned from his repo, honestly. That's how I did it. So just look at his repo and just start, you can find something in there that kind of makes sense about what he's trying to do and just copy and paste it and then just start replacing the things that you want. That's how I did it.
All right, anything else? Did we have any lightning talks?
No, thank you.
Not today, so I guess we're going to go into hacking. I do have